Hello guys! Welcome to my channel, Physics ni Bay. Today, we are going to discuss about light-emitted photons or X-ray production. The photoelectric effect provides convincing evidence nga ang light di ay maabsorb in the form of photons. So, aron ma-accept sa mga physicist ang theory ni Einstein, dapat ma-show pod nga light can be emitted as photons. So, dapat na ay experiment nga bali sa experiment ni Einstein. So, kani nga experiment mauni ang X-ray. So, in the X-ray, instead of releasing electrons from the surface by shining electromagnetic radiation, a surface emits radiation by bombarding it with fast-moving electrons. Mauni ang concept sa X-ray. X-rays was accidentally discovered by Wilhelm Röntgen, a professor of physics in Würzburg, Bavaria, Germany in 1895. He was using a Crookes tube to test whether a cathode rays could pass through a glass. So this is a picture of the Crookes tube with its discoverer, William Crookes. So, his cathode tube was covered in heavy black paper, katong sa experiment ni Röntgen. So, na-surprise siya when an incandescent green light was projected onto a nearby fluorescent screen. So, naay naka-escape nga light. Na-curious siya o naghimo pa siya ubang mga experiments. Now, Röntgen found that X-rays would pass through human tissues too. So, mauni ang iyahang picture. This is the X-ray of his wife's hand with a ring. So, na-excite siya. So, bisan unsa na lang ang ilahang gipang X-rayhan. And even mga stores, ga-X-ray og mga tiil, og uban pa. And later, di ay nila nahibalaan nga dili maayo ang frequent use of X-rays. So, within a year, the doctors from US and Europe, ilahang gigamit ang X-ray to locate gunshots, pag-check sa mga bone fractures, pag-check sa kidney stones, and swallowed objects. O uban pa nga mga diagnostic tests. So, because of the discovery of X-ray, Röntgen was awarded a Nobel Prize in Physics in 1901. Crookes tube. So, unsa man ning Crookes tube? This is basically a glass gas bulb that gives off fluorescent light when a high voltage current is passed through it. So, this is the picture of a real Crookes tube. So, how does it work? So, this is the diagram of the Crookes tube. The cathode is heated to a very high temperature para maabot iyang escape energy. So, escape energy, mao ni siya ang energy nga kinahanglan aron nga maka-escape ang electron sa surface. So, the time nga makaabot na ang iyahang temperature sa escape energy, the electrons are released from the cathode, okay, by means of thermionic emission. So, thermionic emission ang tawag sa emission of electrons from a heated metal. So, same with the photoelectric effect, ang minimum energy nga maka-escape ang individual electron gikan sa cathode surface kay equal sa work function for the surface. So, remember, ang energy sa photoelectric effect kay gikan sa light. Pero ang energy sa X-ray kay gikan sa heat. Okay. Unsa maning gitawag nga Bremsstrahlung? So, Bremsstrahlung is a German word for breaking radiation. So, this is the electromagnetic radiation produced by the deceleration of a charged particle when deflected by another charged particle, typically an electron by an atomic nucleus. So, balik ta sa ato ang diagram. So, in the diagram, the cathode is heated. Then, electrons are then accelerated towards the anode by a potential difference. We call this as VAC. When the potential difference is a few thousand volts or more, X-rays are emitted from the anode surface. So, dito siya mo emit sa anode. So, in the picture there, you have the X-ray beam coming out from the anode. So, the wavelength is mostly ranging from 10 picometers to 10 nanometers, corresponding to frequencies in the range of 30 petahertz to 30 exahertz. So, when we say petahertz, that's 10 to the 15. Exahertz is 10 to the 18. And energies in the range of 124 electron volts to 124 kilo electron volts. So this is the equation for the Bremsstrahlung. You have your E stands for the electron, and VAC is the potential difference between A and C. And then you have H, which is your Planck's constant, which is equal to 6.626 times 10 to the minus 34 joules second, or equivalent to 4.136 times 10 to the minus 15 electron volts seconds. And F max is the maximum frequency, and C is the speed of light in vacuum, which is 3 times 10 to the 8 meters per second, and lambda mean is the minimum wavelength. Note that the maximum frequency and minimum wavelength does not depend on the target material. Therefore, the photon picture of the electromagnetic radiation is valid for emission as well as absorption of radiation. So, example, an electron in an X-ray tube accelerates to a potential difference of 10 kilovolts before striking a target. If an electron produces one photon on impact to the target, what is the minimum wavelength on the resulting X-ray? So find the answer by expressing energies in both the SI units and the electron volts. So what are given? We have the potential difference across A to C, that's 10 kilovolts. And the equation is EVAC is equal to HF max, which is equal to HC lambda minimum. What we need here is the lambda minimum, and we are given with the potential difference, so we can use the equation lambda minimum is equal to HC over EVAC. So the minimum wavelength is 1.24 times 10 to the minus 10 meters, or that's equivalent to 0.124 nanometers. So in electron volts, H is being replaced with 4.136 times 10 to the minus 15 electron volt second, and E is just E, so we have the same answer. So the minimum wavelength is equivalent to 1.24 times 10 to the minus 10 meters, or 0.124 nanometers. Some types of X-rays, sample is mammography. This is an X-ray radiograph that is used to detect breast cancer. So this is the picture of how mammography is done. So this is the mammogram. And you have here an example of the result of a mammogram. So how about the second one, computed tomography or CT scans? Combine X-ray with computer processing to create detailed pictures or scans of cross-sections of the body that are combined to form a three-dimensional X-ray. So this is the sample of the CT scan, and you have also sample of results. Another type of X-ray is fluoroscopy. This used X-ray and a fluorescent screen to study study motion with real-time structures in the body, such as viewing the heart beating. It can also be used in combination with swallowed or injected contrast agents to view the digestive process or blood flow. This is the sample. So you have there the apparatus, and on the wall is the screen. Screen, no, kung asa na paingon ang substance nga ilahang gibutang. Okay, so these are the references used in the pictures as well as some of the articles. So if you like this video, like and subscribe to my channel. Physics ni Bay. Till next time. Thank you.